James Banda. We are going to take you through the presentation on case study reports. So the title of the article that we are reviewing is the ability design of a pressure vessel made of composite materials. So advances in technology have led to an increased improvement in structural performance of engineering materials. Choices of materials is critical since it determines the performance in service. So essentially, engineers look at the following properties when designing: yield stress, Young's modulus, ultimate stress, deformation characteristics. So material properties have an inherent randomness about them. So for example, composite materials, which are new materials and that have just emerged and have a very high demand. So these composite materials, they possess a favorable properties due to their strength to weight ratio. For example, they are mostly used in the automobile industry. So the demand for high-level performance of composite in engineering has led to the deterministic factor of safety no longer being enough on its own as a criteria for safe design. Also, the ability approach is explored to look at the randomness of material properties. The aim of this study is to evaluate the performance of a pressure vessel fabricated from composite materials, grass fiber and carbon fiber, using reliability methods and make comparison with deterministic methods. So in this case, we consider the medium-sized pressure vessel, which was studied in this article. So this pressure vessel is subjected to very high internal pressures. Pressure vessel design. So pressure vessel design, in this case, were designed according to fundamental theories of pressure vessel design. So essentially, there are a number of formulas used in this design, but we only picked a few. So for example, here we have essential theory formulas being used. So we have hoop stress, we have longitudinal stress, and we have radial stress being functions of pressure, internal radius, and thickness. Development of probabilistic theory. So probabilistic theory in this case was defined by considering two normal distributions: induced stress and material strength. So failure was defined as an overlap of these two normal distributions. So illustrated in this figure here. So you see the overlap area between the two normal distributions is what we are defining as the failure zone. So continuing defining failure, so we are saying probability of failure Q defined as probability P that induced stress exceeds the allowable stress. So illustrated mathematically as shown. So consequently, we can define the ability as 1 minus Q, which is probability of failure. Probability function. Resistance varies from membrane stresses is have shown normal distribution. So with S bars meaning standard deviation as QS. So we have we have probability distribution function, and then we have cumulative distribution functions as probability distribution. We have probability density function and the cumulative distribution function. So as shown, those are the formulas. To the left is the probability density function. To the right is cumulative distribution function. So S is assumed to be the difference between induced stress and admissible stress. So the formula for probability consequently becomes as illustrated. So we have a parameter M. So this parameter M essentially has allowed the use of table for calculating standard probability functions. That's M there. So for isotropic materials, M is a function of stress with respect to thickness as illustrated. So for composite material, the resistance value chosen was the best pressure. Therefore, AM values were found to be as follows. So the other part of this presentation is on failure finite element method. So the finite element method for the pressure vessel under consideration was the following. So that is the pressure vessel that was under consideration. So essentially, we have results from longitudinal and hoop stresses. So these are the graphs of stress strain for longitudinal and hoop stresses for the materials, steel, aluminum, carbon, and grass fiber. So continuing from this, my friend James will take you through reliability evaluation until the last slide. Thank you very much. Over to you, James.
All right, thank you, Max. Let me share my screen. Yeah, so regarding the reliability evaluation, average values and standard deviation are applied and applied pressure were used to calculate the component reliability as shown. So the means of these values were tabulated, and that's the radius, the thickness, the pressure, the yield stress for aluminium, steel, yield stress values. This allowed for calculation of different values of parameter M, and then this could be plotted. And from the tables, we could be able to find the percentage reliability. So the graphs of the thickness versus percentage reliability were plotted together with the factor of safety. So the one in green is of particular interest because it is now the graph for reliability against the thickness for the materials. Also for the composites, the graphs were plotted and they are shown below. So, normal distribution curves were also plotted, and they were compared to a normal distribution for the yield stress property of each material. The different thicknesses were applied, and several graphs could be plotted on the same sheet to show the characteristics and therefore the probability of failure and component reliabilities. The PDF for yield stress was given a black color as a reference point, and the blue lines represent the difference between the mean value for induced stresses and yield stress or burst pressures. So this one, the first one is the graph for steel. You can see there that the black curve and the subsequent curves as the thickness is increasing for steel. And then for aluminium, it was also plotted, and you can see there the differences as the thicknesses was being varied. The normal distributions for carbon fiber composite was also plotted, and the initial thickness that was used for the black curve was the smallest, and therefore it was as it was being increased, you could see there that the curves also they moved away from the black curve, and therefore the overlap area reduced. And the grass fiber was also the same that was shown. Now, in terms of results, there is an nonlinear relationship that was shown between the factor of safety and the reliability of the component. Small variations of mechanical properties can lead to significant changes in reliability if factor of safety is near unity. So therefore, the reliability approach becomes indispensable and is a huge asset since the results from the evaluation are similar to analytical approaches. So the advantage of reliability is that it allows evaluation of the influence of an individual variable of a component's performance. There is similarity in terms of performance between composite components and those that are made from classic materials such as aluminum and steel. And because of the 17% weight reduction, the composites have an advantage in terms of applications here. Uh, Now, in terms of the evaluation and relevance of the research, the author demonstrated perfectly how reliability approaches can be used in pressure vessel design. They defined the parameters under consideration, i.e., the induced stress, allowable stress, and yield stress, also burst pressures and induced pressures. They defined the probability density function and the cumulative distribution function. They were also able to plot the graph using derived formulas. And they were also able to plot normal distribution curves to show the overlapping areas where component reliability could be determined. All these steps are areas that the course has touched on and a good application of the knowledge that we have so far gained. The paper also shows the value of reliability when applied to design of pressure containment systems. The results are dependable and it can be applied to full effect in this field. It demonstrates the importance purpose of studying the effect of a single random variable, such as yield strength, on performance components in service. In the service, and therefore the ripple effect would be a reduction in cost because it would be saving in the materials used. So the value of factor of safety could be reduced, and where the component reliability has been found to be very high. In terms of some drawbacks of the study, the calculations for all parameters were not demonstrated. Only graphical results were presented, and the determination of distribution function was not done. The author only relied on previous studies for the determination of distribution, but this was not cited in the text. However, we were able to find alternative sources and authenticate the resistance variable S as having a normal distribution. So the research evaluation was a success. It sufficiently contributes to knowledge in the application of reliability methods, particularly in solid mechanics and pressure vessel design in this case. At this point, we have reached the end of our presentation. Thank you for your time. Goodbye.